10 minutes, but also it's very challenging for me to, probably one of the most difficult session to moderate because so deep and diverse views on embodied intelligence here in the first session. So I just want to take a liberty of just raise one angle to look at all this embodiment issue from the perspective of complex embodiment and simple or simplified principles that some of you came to this point at how the Cecilia talked about the simpler control, or Matt talking about the minimal embodiment. And the free energy principles, predictive codings, and as a scientist, we're trying to extract the simplest principles to understand embodied intelligence. But on the other hand, Yasuo in this plenary session this morning said, simple principles are not enough, but we need to really be conscious about the complexity of our body and complexity of embodiment. I'm kind of wondering what everyone's view on the relationship between simplicity, complexity, and the embodiment. And I just want to start with Andy, what your view on complexity matter, like is complexity prerequisite, or is it something we should avoid discussing? Could you give us a bit of input from your side?
Yeah, I mean, I guess that I think complexity is something that we ought to be discussing. At the same time, and I think this is maybe in line with Matthew's approach there, the basic thing I think we need to understand are perception action loops. Seems to me that that's the thing that underlies everything, and that what we see in studying complexity is just how you can sort of ramp up the interest of perception action loops and different ways to kind of control and bring them about. So in terms of consciousness, the stuff that I was talking about, I think it's a huge question whether very, very simple systems are conscious or they're not conscious. What comes out of our work is the idea that consciousness is graded. And so, you've got a few of these dimensions. There's kind of predictive look ahead, interoceptive richness, kind of action repertoire, depth of your generative model. And, as you ramp all of those up, you end up with consciousness, clearly, like us. And when you move down those dimensions, I think there's probably no answer to some questions like, is the worm conscious or isn't it? It's scoring okay on some of those dimensions and not so well on others. Something that I think Aaron Sloman that you mentioned, or someone mentioned Aaron's work at the outset, would have quite liked, the space of possible minds. So yeah, I think that's sort of my take on it. Complexity really matters. My guess is that all the important principles are really kind of there in perception action loops, and that complexity is sort of the icing on the cake.
Okay, Matthew, do you want to react on this?
Yeah, I mean, I think I have very similar views, and that was kind of one of the main points I wanted to get across in my 10 minutes. But I don't want to detract from the complexity. So if you want to know what it's like to be a human, you need the full complexity of being human. If you don't want to know what it's like to be an octopus, you need the full complexity of being an octopus. And in fact, if you want to understand how contingently on this world intelligence evolved, you need the full complexity of embodiment of all the creatures as part of the process. But the point I really want to make is that any interesting environment with which you can exhibit intelligence in offers a lot of complexity by itself, just in terms of the actions it offers and the interactions it offers to the agent interacting with it. And that, for me, is where you have to build everything up from if you want to look at the very abstract case of intelligence. But of course, if you want to look at a specific case, you need all the complexity involved with each specific case.
Right, yeah, okay. June, I just want to ask you your question about the predictive coding. It's all these predictions and all this neural circuit you need in complexity is because dealing with a complex embodiment and in system environment interactions. How do you view the issue of complexity from your research of predictive coding? You're muted, sorry.
I still don't know. So that is, I often discuss with Kunio-san about the complexity because his system is far complex than mine, or always. So then I sometimes aspire, so inspired by him. So however, so sometimes in order to understand nicely, is efficiently is more simpler or might be good because we can see the all parameter or state things, state representation. So, but only sometimes very complex things can generate more emergent phenomena. So I don't know which one is good. So, but maybe something like it's myself is kind of a robotist. So then I like to like making something. So like a painter paints something, creating something. Then I might interested in more building complex things. But when we think about theory, maybe just a pen and the piece of paper is enough, and writing a simple diagram. And sometimes I come to, aha, this is the same. So very simple thing. So then still, so I don't know which one is good. So I have no answer. So I'm sorry. So yeah.
What do you think is the bottleneck in your research at the moment? Because I see that you build robots, and I see very interesting interactions happening, but obviously complexity is missing in your compared to what animals doing, humans doing. Is this the lack of theory, or lack of technologies, or lack of I don't know what. What do you think?
But I think that we cannot create whole things we cannot reconstruct biological things, right? We need somewhere abstraction. So then where we should stop, that I don't know. So, but it depends on computational power or whatever. So I really don't have a clear answer where I should stop. So how much I should, make things complex. That's I don't know. So yeah, better ask Kunio-san.
Okay, yes, I think it's time to ask Yasuo. So you have kind of moved your research direction to the simulating very complex fetus model, and I think that's one way forward to really deal with complexity. And I don't know what's your view on the simple principles versus complex embodiment? So yeah, okay.
Yeah, okay. Maybe I said, so I'm building a quite seemingly complex model because I feel some risk of, focusing on a too simple embodiment would first limit. I mean, it's like a design issue. How do I say? So if you design a low degrees of freedom, simple body, then inevitably you're imposing limited functionality or limited characteristics on the body. Like, for example, take the passive dynamic walker. It's the structure already is quite specifically, constrained to the kind of behavior like the walking, and they cannot do like various other things, right? So that's one thing. So I'm insisting on a rather complex human-like embodiment because I don't want to constrain the embodiment to end up with a limited variety, like it's a design bias. So I want to avoid that. Another thing is that probably it's not complexity which is important in this case, in my baby simulation, but it's the sort of accuracy, So I'm interested in human embodiment, and I want to make the model as close as possible to human embodiment from certain aspects. It's not everything. So as Jun said, we cannot reconstruct all the living organisms, all the details. The one thing is that as Andy Clark said, the perceptual action loop. So from that aspect, I want to be very accurately capture what kind of interaction dynamics takes place. And for that, I had to put a lot of effort in making the musculoskeletal and physical body as precise as possible to be for that, so that the interaction dynamics becomes similar to human case. So the point is twofold. One is I want to avoid the sort of a design bias limiting to a particular specific functionality or behavior pattern. Another is I want to be close as possible to my target of understanding, the human, and in terms of perceptual motor interaction dynamics.
Okay. Okay, thank you. Yeah, so I think it's time to ask Cecilia about the perspective from robotics, and especially from soft robotics, because I think one of the reasons we're interested in soft robotics because we want to increase the complexity, but also make our robots similar to biological systems. But on the other hand, you start talking about simple principle, simple control, and I think that's all connected to each other. I think. What do you think? Your views on simplicity versus complexity discussion?
No, I agree completely with Yasu. I mean, complexity is what we want. We want to be able to have complex robots. I mean, complex enough to work well in a complex environment, because in robotics we also simplify the environment very much when we use our robots. So this is what we have to learn as roboticists. We have to learn to do complex systems, complex robots working in complex environments, but we need simplifying principles to make them work in a simple way. And this is exactly what nature does. I mean, years ago, I was talking with a neuroscientist, and I said, okay, yes, humanoid robots, sometimes they fail because they are complex. And he said, complex? They are too simple, way too simple. They cannot work because you need many more actuators, many more sensors. How can you think that they can work properly in the real world? I mean, you simplify too much when you build your robots. So it's really an opposite vision. But what nature, let's say, evolved in millions of years for many animals are simplifying principles. So you know that in neuroscience, there is the word simplexity to mean exactly this. So complex system, complex environment, but some tricks for which brains can select the proper input, sensory input to process and exclude the others that are not relevant. So this kind of inhibitions or, other tricks by which you can, the system can respond promptly and the behavior and the control becomes simple. But complexity is exactly what we want.
Yeah, okay, thank you. So it looks like all robotics types, including myself, agrees its view on how the complexity is the key for robotics, and but we still cannot really compete with the complexity of biological systems that we're struggling with. Barbara, I think it's your turn now. You have experience in both robotics and biology, and I don't know what your view on this topic, and if you realize the pitfalls for biologists or pitfalls for roboticists to think about the complexity, simplicity issues. And do you have any views, comments on this?
I think people have probably said lots of things already, but I guess the one thing I would say is, where, as the examples I gave probably illustrate where I lean towards what I enjoy most is when I find a simple explanation for something complex. And where I kind of hold myself to the complexity is either the task, in the sense that, you know, it has to work in the real world. So that injects, once you're in the real world, you've got so much complexity. You may still be able to find a simple, elegant solution that works there, and that's fantastic when you can, particularly if, you know, if you can find it in nature and then copy it. And then the second one is, you know, in the work I do is very closely based on the biology. So I kind of skipped over it a bit in the talk, but it was very important to us to show that when we had this crawling behavior with a simple control system, we could nevertheless reproduce nearly all the statistics that the real animal has of the behavior. So it's about, you know, you have some actual target in the real world that you're trying to imitate. And again, that imposes the complexity because you know what that animal is capable of. And you know, recently, Jane Lovelace has been working on actually going into the third dimension. So having a 3-dimensional maggot that can turn and so forth. And surprisingly, still being able to find some very nice simplifying principles that are very, very descriptive of the behavior that happens. So I think this is, you know, I think we don't understand things if they're too complex, I guess is the problem. But we don't want to, you know, we can't just make a complex, an arbitrarily complex thing and say, well, now that's more like biology because it's arbitrarily complex. It might not be, it might still be complex, but nothing like a biological system. So I think it's, you know, I'd rather have the complexity come from the task constraints or the target behavior that you're trying to imitate. And then you build the system as complex as it needs to be for that, given those constraints.
So, yeah, Jim, you want to comment
I
on this?
have one proposal to think together. That is, this conference really unique because two different way of thinking people gathering. That one is soft robotics. That is more on reactive behavior, soft robotics people, and then more sensory motor mapping, and more kind of embodied novel AI like Brooks and Pfeiffer proposing, and denying the planning or prediction or inference. But the other side is predicting active inference free energy like me, and more about planning that is once denied by the novel AI people, the inferencing, those things we are saying important, but still we want to embody it. But these two really extremely two different sizes now together, right? So, but both are, you know, looking at the complexity because, and then this soft robotics people these days are using reservoir computing. It's kind of internal rich complex things comes and they utilize it, but without inferencing. So, and then what do you think about this? So you are, I think, Fumiya-san, you are more soft robotics, but Kunio-san is doing, looks like interesting both sides. And Andy is, I think you are more predicting active free energy person. And Barbara is more sensory motor, but you talked about the prediction a little bit. And Cecilia is more soft robotics. And I don't know, so is that good things to discuss or not?
Absolutely. Andy, do you want to react to this comment?
Yeah. I mean, it seems to me that one place where this comes together is the idea of complex systems that use simple models to understand complex worlds and indeed to control their own bodies. And I think one place where you can sort of easily bring the viewpoints together, thinking about how those simple controllers emerge out of complexity. Which I think is really what the predictive processing active inference people are trying to do.
Okay. Any other comments?
No, I think we needed a philosopher. Thanks, Andy, because you expressed this very, very nicely. I think you really get the point.
So one of the questions, as a roboticist, asking all these biologists and philosophers, because we are always suffering to make our robots more complex and more animal-like and so on. And I think Barbara has. I don't know. I actually want to ask Barbara about this question. Like you did lots of robotics in the past and move more and more to the biology research in the later years. And is this one of the reasons why you moved, because you struggle with make robots more complex and or is it easier to study animals, or what's the reason behind this transition?
Yeah, I wouldn't say it's such a transition, in that I think the robots I've built have always been intended as models of animals. But I think what's, at least key in the way I approach things is that I do want to have a real animal target. So I don't want to build evolve an agent that has some arbitrary relationship to biology. I actually want to build something that is actually like a biological system, because biological systems are so impressive. So, even as a pure roboticist, you can't help but admire what even a very humble insect is able to do. And, I think someone mentioned the grasping problem came up a couple of times, and that's something I'm just about to start a new kind of research program on. How do ants grasp objects? Because they're fantastically good at picking up amazingly varied objects that they've never experienced before in cluttered, awkward conditions, and they do it with a very tiny brain and with very simple grippers. They don't have a complex hand. So they just outperform our robots so amazingly that I just want to understand what they're doing and how they're doing it. And it feels like I guess that's why. Yeah.
Right. Yes, and I also want to ask Andy and Matthew, especially, what you would like to learn from robotics, or did you actually learn anything from what we're doing in robotics discipline, or is it helpful what you would like to see from us? This is a kind of very interesting discussion, at least from a robotics point of view. I don't know, Matt, do you want to start with you?
Yeah, so to solve the problems, ultimately, you need the robotic side of things. What I want to do, and what I have been doing in simulation, is good for getting down to maybe just the cognitive aspect of a task and what the minimal objects you need are to set up such cognitive experiments. But that's going to be fairly useless if ultimately you can only ever do it in a simulated world and you can't translate it into the real world. And for that, I have nothing to offer because I don't know the answers to that, and you all guys, all of you lot, have much better answers. And I think we will find some really interesting stuff though in the sort of intersection where, a lot of the robotics work seems to need to be about getting the simplicity of your controllers down so that you can deal with the complexity of existing in a very noisy environment. And once you have that down, that's going to have to interact with how the system is modeling the rest of the world at a higher level of abstraction. So there's no way that you can progress to the final goal without both sides coming together.
Yeah. So Andy, do you want to add on?
Well, certainly, I adore all the work in robotics. I think it's been a constant inspiration. The whole picture that I've been interested in, I think, owes an awful lot more to robotics than it ever owed to good old-fashioned artificial intelligence or anything like that. I guess in terms of what I'd like to see a bit more of in robotics, I guess the answer is interoception. And so, in the predictive processing work that I'm looking at on active inference, interoception is playing a hugely important role. It's kind of inflecting everything. All of those perception action loops looking outwards are inflected by the internal state of the system. And I think that could be really important. It might be a point of discussion with Matthew, because I saw that when Matthew had kinds of intelligence, one of them was a pure internet like crawler or something. And I couldn't help but think at that moment, yeah, but it's not got any matter in. There's no sort of deep allostasis or sense of, a viability envelope for survival. So I wasn't sure that that one belonged in there. But to me, it's a kind of open question whether interoception is an essential ingredient of general intelligence, conscious experience, any of those things, or whether it's somehow an optional extra. But I certainly like to see it explored a bit more in robotics. Yeah.
Can I make a brief comeback to that?
Yeah,
So I think it's important that that agent is in there. Okay. There's a version of that agent that shouldn't be in there, and that's the agent that gets an set of inputs from like the internet, does some processing on it, and then gives an output, and then ignores everything else. But if it is temporally embedded, so that the data that it has access to is continually changing over time, and it needs to keep an updated model of what is currently going on in its abstract environment, then it needs some kind of internal state, because it needs to keep a memory of what the external state is like and to do inference over it. And that, to me, is enough to like build upon to have this internal external distinction, and the internal state needs to be rich enough to model all the complexities of its environment, and therefore also needs to start, you know, doing maintenance over its internal state and doing internal calculations over it. And so that brings in all that kind of stuff, at least for me.
Maybe at that point, that sort of internal maintenance of some kind, because otherwise I just have this feeling that nothing would matter. You know, there's something about real intelligence and things mattering that somehow matters. I don't think we fully got to grips with, but yeah.
So very, very briefly, if that agent can't answer counterfactuals about what its environment would be like if it was another way, then I completely agree with you. But as soon as you include that type of generality in its intelligence, that it can answer all these type of counterfactuals and answer what would happen if it impacted its environment in a certain way, then it needs the rest of the rich machinery of introspection, in a sense.
Yeah, okay, good. That's interesting, thank you.
Okay, good. Okay, go ahead. Andy, you want to add something? Okay, sorry. So, yeah, I think this was a great start of discussions, and we will have a lot of following up on this discussions. The first thing this afternoon is we have a plenary speech by Carl Friston about the free energy principle, obviously. So this is directly related to what we have been discussing here. And then we're going to have a lot of speakers from soft robotics, and material science, and so on. So I think this is a really, really good start of discussion of this workshop. And there are also some questions posted in the Discord where you can probably continue this discussion after this session. And I'd like to close this session for now because I think we just need to do a bit of housekeeping for this afternoon session. So thank you very much, all the panelists this morning. I'm sorry for the very tight time schedules for discussion, but I think this was a very good exercise of interdisciplinary discussions for very stimulating, exciting topics, and hopefully we can continue with discussion over the workshop.